at least one of the reasons why we're now more and more convinced that the holographic principle is really something that works comes indeed from string theory, which is my field. And what happens there is precisely if you go through this step of looking more and more detailed at what happens on shorter and shorter distances, you might be interested in say, what happens inside of our nucleus, inside of our atoms, and there's a nucleus, and there are quarks, and there are smaller and smaller particles. And suppose, again, that for a moment you would want to forget about gravity, but you start looking more carefully at what we're made of. And then because of this idea that when you start looking at smaller and smaller scales, or at least at smaller and smaller distances, suddenly you discover that there's actually something new happening. And that something new, at least in terms of your equations, you recognize it as gravity. So the amazing thing is that while you're actually interested in just looking at the smallest constituents of matter without putting gravity in, gravity comes out as something that's sort of inevitable. And to me, there's an enormously deep lesson there. That
interesting mathematical game. String theory was the first time where we wrote down a theory and we said we want it to live in a certain number of dimensions, and these strings have to move around and they must obey the rules that we already know nature likes, which is that it has to be relativistic and quantum mechanical. And you put those two ingredients in, and the theory comes back and it gives you a list of demands, and theories didn't do that before. It comes back and it says, I'm not going to work unless you work in, in the version that's most well understood, unless you work in 10 dimensions and unless you describe gravity. So we put that in. We didn't ask for it to be in a fixed number of dimensions. And we didn't ask for gravity. It came back and told us gravity has to be in the game, and you have to have a different number of dimensions than you thought. And that was just historically, and even at the time, was really shocking.
String theory was that in string theory, there's much less arbitrariness. One of the great features that attracted many of us to string theory was that you don't have the freedom to decide what kind of space-time you're going to live in. That's dictated, and it turned out to be more than 3 spatial dimensions in many solutions within this framework. So that's how